Lesson 4.7. Complete the square. We have solved quadratic equations by factoring and by taking square roots. But you can only factor some quadratics. And the square roots only works when there's a single x. So we need some method to solve all the other quadratic equations. We can do that by completing the square. The perfect square, something like that, x plus 3 squared. If I multiply that out, x plus 3 times x plus 3, FOIL it, we'll have our first x squared, outers is 3x, inners is 3x, and last is 3 squared. Combine like terms, and 3x plus 3x is 2 times 3x. Which of course gives us x squared plus 6x plus 9. But let's look at that previous step. In general, we can say that x plus k squared is x squared plus 2 times k times x plus k squared, just like we saw with the x plus 3 squared. So let the k be 3, and you have the same thing. If we compare that to our standard quadratic form of ax squared plus bx plus c, we can see that when a is 1, the c would be half of whatever b is squared. So our c will be 1/2 of b squared. So what should we let c be to make this a perfect square? Well, it's 1/2 of b squared. In this case, b is 8. So it would be 1/2 of 8 squared. Half of 8 is 4, and 4 squared is 16. So c should be 16. Let's solve by completing the square. Start by rewriting the quadratic so the x terms are on one side and the constant is on the other. So it looks something like you see. If the leading coefficient is not 1, then divide everything by it. If you look here, it's 1x squared already, so we don't have to worry about that step. Complete the square by adding 1/2 of b squared to both sides. So we're adding what the c should be to both sides. See here, b is 6, so I'm going to add 1/2 of 6 squared to both sides. Simplify that. 6 over 2, half of 6 is 3. We're squaring it. And 3 squared is 9. So here I have the 3 squared. Here I wrote it as 9. You can write this one as 9. It's fine. We rewrite the left-hand side as a perfect square. So we factor it. It'll become x plus 3 squared. All right. Shortcut way to get that. It's x squared, so we have an x. This is a plus. And the 3 from there. So if we had written this as a 9, we had to remember to square root it to get the 3. So that, and that. And now, notice we have 1x and it's squared, so now we can solve by taking square roots. So we'll take a square root, don't forget the plus and minus, and subtract the 3. But don't leave your answer like that. Finish simplifying if you can. Negative 3 plus 5 is 2, and negative 3 minus 5 is negative 8. So our answers are 2 and negative 8. So let's try another one. Move the 12 to the other side. we need to divide by 2 to get the a to be 1. See here we have 2x squared. We need this to be 1x squared. So divide everything by 2. Now we complete the square. So I need to add 1/2 of my b. b is 11 over 2. So you need to add half of that squared to both sides. Half of 11 halves would be 11 fourths. If you don't know, just multiply straight across, you get 11 over 4. Now we write the left-hand side as a perfect square and simplify. So it's going to be x minus 11 fourths squared. On the right-hand side, I simplified a little. 11 squared is 121, 4 squared is 16. To add the fraction, we need a common denominator, which would be 16. So 6 is the same as 96/16. Add these. Negative 96 plus 121 is 25. Now we can take a square root. So square root both sides. Don't forget the plus and minus. Then add the 11 over 4. So now 11 fourths plus 5 fourths would be 16 fourths, which is 4. And 11 minus 5 is 6 over 4, which reduces to 3 over 2. So our answers are 4 and 3 over 2. The area of this rectangle is 56. Find the value of x. Since it's a rectangle, area is length times width. Our length is 4x and the width is 2x plus 3. The area is 56. Multiply, so we're going to distribute 4x times 2x is the 8x squared. 4x times 3 is 12x. We need to divide by 8 to make this 1x squared, to make the a1. So 12 over 8 is 3 halves. 56 over 8 is 7. Add 1/2 of the b squared to both sides. Half of 3 halves is 3/4. So I'm adding 3/4 squared to both sides. On the left, I rewrite it as a perfect square. It will be x plus 3/4 squared. And here, this 3 squared is 9, 4 squared is 16. To add these fractions, remember to get a common denominator. 7 times 16 is 112. Plus 9 gives me 121. Take a square root, which becomes 11 over 4. Subtract the 3/4 and get our answer. Negative 3 plus 11 is 8 over 4, which is 2. Or negative 3 minus 11 is negative 14, which is negative 7 over 2. I can only use the positive answer, so we're going to go with the answer of 2. We also can use completing the square to write quadratic functions in vertex form. Remember, vertex form was y equals a, x minus h squared, plus k, where hk is the vertex. So we're starting with standard form here, such as this one. We're going to complete the square with a little small twist. Group the terms with the x, so put parentheses around them. And then factor out any number in front of the x squared. So I need to factor out the 2. Now add 1/2 of b squared to both sides. On the group, it's going inside the group. So inside the group, I have 1/2 of 6, which is 3, squared makes 9. So 1/2 of 6 is 3, squared is 9. So I added 9 here. I'm going to add 9 here. But this is inside the group, so it's really 2 of these 9s. So I need to add 2 of the 9s over here. Rewrite it as a perfect square, so it'll be x plus 3 squared. And then simply subtract the 18 to get the y by itself. And now it is in vertex form. The vertex is at -3, -2. -2 is the minimum. That's the y value of the vertex. And so you can find the maximum or minimum by completing the square to find the vertex. And that's all for today, folks.